PETRONAS two-teller hydraulic fluid for DRS, another weapon in boosting speed in a Formula One car's arsenal. DRS is something we often hear about, but what does it actually do and how does it work? And how does the two-teller hydraulic fluid assist? Welcome and thank you for joining us for this episode 5 in this 6-part series where we delve deep into the 5 PETRONAS functional fluids. Today, more specifically, we're looking at the two-teller hydraulic fluid for DRS. So if we jump straight on in here, I think it's often something that seems quite simple, a DRS flap that opens and closes. But how does it actually work out on track?
Well, as you say, it's deceptively simple. And any kid who's ever stuck their hand out the window of a car on the motorway will know exactly what the feeling is when you change the angle of attack of your hand and you feel that incredible force from the wind. Only in our case, we're doing 340 kilometers an hour. So we've got much bigger kids, much bigger cars, and a much more difficult job to do. What we're asking that flap to do is open against the force of the wind, right at the beginning of the straight when the driver needs a burst of speed, reducing the drag on the car and giving them the ability to accelerate down that straight with maximum speed, and more importantly at the end of the straight, closing up again when he needs the downforce at the most critical moment under braking.
And we do all that by a hydraulic actuator. So is there a reason why we use hydraulics rather than using a cable?
Yeah, of course it is. The driver wants immediate reaction when he pushes the button. The flap needs to go down and up. The hydraulic system will guarantee this immediate reaction.
We're really putting Torre and the other engineers from PETRONAS in a difficult position because we're demanding 2 big things from them. We're demanding a system that's very reliable and is going to actuate time after time, as you say, maybe 70 times during the course of a race. But we're also demanding a system that is incredibly performant, so that we want it to be reliable and function time after time, but we also want it to operate within a few milliseconds. And those 2 things are quite hard to balance.
So it'd be great now to take a zoomed in look. Would you mind talking us through it, Evan?
Yeah, absolutely. So of course what we're looking at here is the whole car, and we're zooming around to get an overhead view of some of the critical elements. So if we can pause in this area, of course we're seeing the power unit from above, and this in the end is the source of all the hydraulic power. We have a hydraulic pump on the engine that's mechanically driven from the engine, producing hundreds of atmospheres of hydraulic pressure that would be used then through a valve to drive all the way up this line to the rear wing. So you imagine when the driver presses that button, on the one side of the valve, we've got 200 bar or so of hydraulic pressure, an incredible pressure. On the other side, you've got a couple of meters of line going to that rear wing. He presses the button and we get a burst of hydraulic power up that line, actuating the rear wing. And I imagine from Salvatore's point of view, the length of that line alone introduces some challenges.
Yeah, of course. So you need to guarantee the right viscosity. So we develop the fluid quite close to MGP in order to guarantee the best trade-off in viscosity. So not too thin, not too thick.
And if you hit that sweet spot, of course, you need to then keep it there through all the race. So you might have the viscosity at the beginning of the race, the temperature of the whole system changes. By the time you get to the end of the race, you want exactly the same characteristics. And we're pretty demanding from that point of view. So now we're looking at the actuator on the wing itself. So we can see here the hydraulic actuator and then a linkage down to the center of the wing that's actuating the flap, and what you'll be used to seeing on television. The actuator itself is normally hidden, and of course that's producing an incredible force, and just in a few milliseconds producing that opening of the wing.
We also want that reaction, that actuator to move as quick as possible, as we said, and compressibility is a key factor there. We also need to guarantee full compatibility between the fluid and all the materials around the system and all the seals in order to guarantee full reliability and guarantee also, on top of that, wear protection.
Because we're asking you to operate in a pretty dynamic environment. So not only is it vibrating, is it incredibly high temperature, but of course, as you say, the wear is important because we might be doing this hundreds of times. If we're in a really dynamic and close-fought race, we might be a second from the car ahead many times over the course of a race. So the driver will be doing this actuation time after time, and they'll be in our ear shouting if it doesn't go right even once. Of course, the hydraulic fluid that is being produced by PETRONAS is being used in this application in a way that's very different than a conventional hydraulic application. We're taking this fluid, we're accelerating it to 350 kilometers an hour, we're vibrating it, we're heating it through a massive range of temperatures over the course of the race, and we're throwing it around the corners at ridiculous accelerations. It's a bit of a special requirement.
Thank you both so much. So there you have it, the PETRONAS Tutela hydraulic fluid for DRS gives us that reliability, performance and precise hydraulic boost exactly when we need it out on track to assist with our overtaking manoeuvres. Join us next time as we take a closer look at the clutch.